Hi everyone, in this lesson we're talking about solving systems of nonlinear equations. And we're going to do a warm-up to sort of demonstrate what we mean by that. But basically nonlinear systems are systems where we have at least one equation that's not a line. So we have a warm-up, draw a parabola and a line with no solution. So a parabola and a line with no solution means that they're not going to touch in any place. There's no intersection point. The next one says draw a parabola and a line with one solution. That just means that they're going to touch in one place. Or draw a parabola and a line with two solutions, so it could look something like this. We have two intersection points. So those are examples of nonlinear systems, graphically speaking. So it says, what is a system of nonlinear equations? That's a system of equations where one or more equation involved is not a line. So example 1, it says solve the system algebraically. So what we're going to do is find the intersection points, or the points where the equations overlap, just like we did graphically in the warm-up. These are the points where they share the same value and the points where the equations are equal. So if we're going to solve this algebraically, both of these systems are equal to y, which means we can then set them equal to each other and go ahead and solve. So I'm going to add x squared to both sides. Divide both sides by 2. Then I'm going to take the square root of both sides. When we take the square root of both sides, we get x equals plus or minus 2. So that's the x part of the solutions for these. It says find the corresponding y values. We would do that by substituting these x values back into either one of the two original equations. Well, this is the easier equation, so that's what I'm going to use. But let's just make a note here that we have two coordinates. We have 2 and we have negative 2. And to find y, we're going to substitute each of those values into the equation y equals x squared. So we have y equals 2 squared, so y equals 4. And we have y equals negative 2 squared. Here for this point, y equals 4 as well. Example 2, again, we're going to solve the system algebraically, which means we're going to set them equal to each other and solve for x. I would suggest pausing the video and trying this on your own, but fair warning, you're going to need to use the quadratic formula. All right, so I'm going to put x squared plus 3x plus 2 on the left side and 2x plus 3 on the right side. It doesn't matter. You could switch the sides if you want to. I like to work primarily on the left side and get 0 on the right side. So I'm going to subtract 2x from both sides, and I'm going to subtract 3 from both sides. And by looking at this, we can tell it's not factorable. Since it's not factorable, we would have to use the quadratic formula. Quadratic formula is going to be negative b plus or minus the square root of b squared minus 4ac over 2a, and you should have that memorized. In this case, the value of a is 1, the value of b is 1, and the value of c is negative 1. When we simplify that, we're going to get negative 1 plus or minus root 5 over 2. So we get two solutions. We get negative 1 plus root 5 over 2, and we get negative 1 minus root 5 over 2. And we would take those values and put them back into either one of the equations to find the value of y. Now, to make this a little simpler, I'm not going to use the exact values. I want to convert both of these guys over to decimals that are a little easier to work with. All right, so -1 plus root 5 over 2 rounds to 0.62, and -1 minus root 5 over 2 rounds to -1.62. So I'm going to use those values from this point on. And I'm going to take each of those values and substitute it into one of these equations. And this equation is definitely easier, so that's the one I'm going to use. But you could use either one. So the first coordinate I get is 0.62, 4.24. And then I'm going to substitute in the other x value. So the other coordinate I get is -1.62, -0.24. Now on the next page, we're going to solve that same system, but this time using the graphing calculator. So we had two equations. We're going to put the first equation in y1 and the second equation in y2. Then we're going to zoom in using a standard window, and then we'll calculate the intersections using the second trace number 5 intersect feature, and we should get the same solutions. Remember, the solutions we're expecting were -1.62, -0.24, and 0.62, 4.24. So we're going to go to y equals, and you're going to enter in the two equations. Then we're going to go to zoom 6 to look at a standard window. And we see that we have two intersection points. So we're going to go to second trace, number 5. And we'll move our spider to the near the first intersection point. It says first curve, we're going to hit enter, second curve, hit enter, third curve, hit enter. And we do get an intersection at -1.62 and -0.24. So that would be this guy right here. All right, now let's check the other intersection. Second trace, number 5. And again, we're just going to move our spider near the intersection we want to find. Hit enter, hit enter, hit enter. And we get 0.62, 4.24, which is this one. All right, so it says, remember, the picture can give you a good idea, but only the algebra can give you the actual answer. So if we wanted an exact solution, remember, we would have to go back to these values. These are the exact solutions. The solutions that we've been looking at are rounded. It says solve a system of nonlinear equations by rewriting the system. So say we get this as our problem. What we could do is just rewrite it. We could put this as y sub 1 and this guy as y sub 2, rewriting that system. And then we would put those into our calculator and we would find the intersections. So let's go ahead and try that. We're going to go to zoom 6 for a standard window. And we'll calculate our two intersection points. We're expecting two solutions because we have two intersection points. Second trace, number 5. Move to the intersection you want to find. Hit enter, hit enter, hit enter. And the first point we get rounded to the nearest hundredth is -1.18. And the y value is -2.73. All right, let's find the other value. Second trace, number 5. Move over to that intersection. Hit enter, hit enter, hit enter. And we get 0.43 and 1.67. All right, now we're going to look at a real-world problem using the formula for distance, and that's rate times time. car passes a parked police car and continues at a constant speed of r equals 0.8 miles per minute. The police car begins accelerating at a constant rate when it is passed. The distance in miles the police car travels as a function of time in minutes after being passed is represented by the equation d equals 2.5 t squared. Write and solve a system of equations to find how long it takes the police car to catch up to the other car. We're going to solve it algebraically, and then we'll check our answer via graphing. So we have two equations. So we have one equation, and the other equation we have to formulate because we're given that the rate is equal to 0.8 miles per minute. So our formula is distance equals rate times time. So the other formula is distance equals 0.8 t. All right, so we have a formula derived from this bit of information, and then we have this formula. So that formula is d is equal to 2.5 t squared. Now, if we want to solve this algebraically, they're both equal to d. So I can set this equal to this and solve it algebraically. So let's do that first. I'm going to move the 0.8t over to the left side, so subtract 0.8t from both sides. Factor out a t. So we'd have two equations that would come out of this algebraically to solve for t. We'd have t equals 0, and we'd have 2.5t minus 0.8 equals 0. Well, we know that t can't equal 0. The time can't equal 0. That doesn't make sense in context of the problem. And then if we solve this one algebraically, t is equal to 0.32 minutes. Okay, now we'll check that on our calculator. We'll go to our graph. We can zoom 6 if we want. We already have a standard window, or just hit graph. And we see that we have, it looks like 2 points, but it's really hard to see. So I'm going to zoom in on this graph. Go to zoom. We're going to hit number 2. And wherever your little spider is exactly where it's going to zoom. So I'm just going to hit enter. Now we can see that spot a little bit better. And again, you could just barely see that it's intersecting in two places. So I'm going to zoom in one more time. Zoom number 2. I'm going to move this little spider just kind of in between where it's intersecting. That's much better. And we know we have an intersection point at 0, but that doesn't make sense in context of the problem. So we're just going to check this intersection point. Second trace, number 5. And again, we just have to move our spider near that intersection point. Hit enter, hit enter, hit enter. And we get a value of 0.32, confirming what we got algebraically. Okay, this last page is for practice, and this page I would say you should pause the video, try these, and when you're ready, come back and check your answers. So we want to solve these algebraically and by graphing. To solve them algebraically, I'm going to set them equal to each other. Then I'm going to add 2x squared, add 16x, and add 30 to both sides so that I can move everything over to the left side of the equation. And now I'm going to factor that. I could see that I could pull out 3 out of every term. I have a GCF of 3, so that's going to make my life a little bit easier when I factor. And then I'll factor that quadratic, set x plus 4 equal to 0, and I get a value of x equals negative 4. Now, if I want to know the y value, I would have to put negative 4 into either one of those equations. So I'm going to put negative 4 into the first equation. So my output value when x is negative 4 is 2. So I get a value of negative 4, 2. So now I'm going to check that using my calculator. Do zoom 6 for a standard window. And we can see there's one intersection point, second trace, number 5. Move our little spider near the intersection point. Hit enter, hit enter, hit enter. And we get a value of -42. So we've confirmed our first solution. Going to the next one, we're going to set them equal to each other. Subtract x from both sides and subtract 5 from both sides. Factor and solve. So we get a value of x equals 3 and a value of x equals -1. Now using the first equation, when x equals 3, the y value is going to be 8. 3 plus 5 is 8. And then when x is -1, -1 plus 5 gives me 4. So the two solutions that I believe I have are 3, 8, and -1, 4. All right, we'll check those in the calculator. Go to y equals. We're going to clear both of these out. Zoom 6 for a standard window. Second trace number 5. Move near the first intersection, hit enter, hit enter, hit enter. We get -1, 4. Okay, that confirms one of our solutions. Second trace, number 5. Move near the other intersection point. Enter, enter, enter. And we get 3, 8. All right, so we confirmed those solutions. Moving on to number 3, set them equal to each other. Add x squared to both sides and subtract 7. I'm going to pull out the GCF, which is a 2. That's the difference of squares, so I'm going to get x minus 2, x plus 2. So I get a value of x equals 2 and x equals -2. If I put 2 into this equation, 2 squared minus 1 gives me 3. If I put -2 into this equation, I also get 3. Confirm in the calculator. Zoom 6. Second trace number 5. Enter, enter, enter. We get -2, 3. That's one of our solutions. Trace number 5. Move near the second intersection point. Hit enter, hit enter, hit enter. And we get 2, 3. We confirmed those solutions. Okay, number 4, we get x squared minus 6x plus 14 equals 5. Subtract 5 from both sides. When we factor that, we get x minus 3, x minus 3. We get a value of x equals 3. If we put 3 into the first equation, 3 squared is 9, minus 18, plus 14, we get a value of 5. We'll check that in the calculator. Hit graph, we're already in a standard window. And we see we're going to get one solution, which is what we're expecting. Second trace, number 5. Move your little spider And if you're not sure where the spider is, because we can't see it right now, you can tell by looking at the x value. So it's at 0.6. It's almost at 1. And if you look at the graph for x equals 1 or almost at 1, it's up here. So we have to keep moving the arrow to move him down. All right, that's close enough. We're going to hit enter, enter, and enter. And we get a value of 3.5, which is what we were expecting. Okay, 2 more. Set them equal to each other. Add 3x and add 17 to both sides. Now that doesn't look fun to factor, but I am noticing that I could pull out a -3, and that would make factoring much easier. And that factors to x plus 3 and x plus 6. So my solutions for x are -3 and -6. So I know I'm expecting 2 coordinates, -3 and -6. If I put -3 into this equation, -3 times -3 is 9. 9 minus 17 gives me -8. If I put -6 into this equation, -3 times -6 is 18. 18 minus 17 gives me 1. And I'll check those in the calculator. I'll do zoom 6. We see our 2 intersection points. We're going to do second trace number 5. We're going to start moving our spider. Our spider is almost at -1, which means it's off the graph, so I have to keep moving it left. All right, now it's near the first intersection point. Hit enter, hit enter, hit enter. I get -3, -8. That's one of the values I was expecting. Second trace number 5. Move over to the other intersection point. Hit enter, hit enter, hit enter. And the other value I get is -6.1. I'm just demonstrating you could do these algebraically or you could do them graphically. Obviously, if you have your graphing calculator, that's the way to go. But if you don't, then you would have to do it algebraically. So last one, set them equal to each other. I'm going to subtract 2x squared minus 20x and minus 44 to get everything over to the left side. Looks like I can pull a -5 out. That will make factoring a lot easier. Factor and solve. I get x equals -6 and I get x equals -4. So I am expecting 2 coordinates. If I put -6 into either equation, I'll get a value of -4. And if I put -4 into either equation, I'll get a value of -4. So last one, let's check it on the calculator. Go to a standard window. Look for our intersection points. Second trace, number 5. Start moving our little spider. It's almost to -1, so I have to keep going left. There it is. Okay, hit enter, hit enter, hit enter. First point is -4, -4. That's what we were expecting. Second trace, number 5. Move it all the way over to the other one. Enter, enter, enter. And we get a value of -6, -4. All right, thanks for watching to the end. Have a great day.